Okay, we're continuing the Money Button documentation series, and now we're going to talk about public keys. So in the last video, we talked about private keys, and we're separating these three videos. So private keys, public keys, and addresses, they're related, but they have to do with different parts of the library BSV, and they're sort of conceptually different and so on. So we'll provide links to all of them as well as all the rest of our documentation. So public keys. So let me just sort of immediately dive right into my terminal and show you guys this stuff here. So as usual in my little terminal here, where I have BSV set up and I can easily load BSV, the library, to do stuff. So I'm going to start, instead of making a public key, I'm actually going to make a private key, because normally the way you would do this is to make a public key from a private key, which is what I'm going to do. So let me start by making a new private key equals bsv.privatekey.fromRandom. And I should comment, we didn't say this earlier, but actually we are using a cryptographically secure random number generator for this stuff, which does matter. Node.js has that built in, and modern web browsers do have cryptographically secure random numbers, which is what you want. You don't want to use math.random ever. You want to use, in the case of a web browser, it's crypto. I think it's get random values or something like that is what's used inside a web browser. And Node has its own on crypto. It's a crypto library. It has a random number generator that's being used here. So anyway, with a private key, what we can now do is we can generate the corresponding public key like this. I say public key bsv.public key.from private key, and then type in the private key. Now I can do things like I'll print out my private key. This is just a new random one here. So choose string, see what it looks like, and then see what my corresponding public key looks like. Now,
you do the and private key.
Thank you. So this is, I was saying before that it's compressed. So there's something interesting. So it always starts, I don't know about always, but I think it does actually. I think basically compressed is, I think it's always a 3 if I remember. No, I think it's either like a 3 or a 2, something like that. It's a 3 or a 4 or 3 or a 2 or something. But it's 33 bytes long, because if I say something like public key dot point, this is kind of an interesting thing to look at. So a public key is a point. So we say something like public key dot point dot get x. And that's actually a number. Then I could say public key.point.get y is also a number. So this is actually a point, because remember we talked about things where basically a public key is a private key times g, which is the base point of the curve. We should actually be able to rederive this if we want to. So we can do things like I have the public key point right here, and I can do things like take my private key dot number, which is .bn, and then I could say something like bsv.crypto.point.getg.mol times private key bn, and that should get me a value .get x, and then get y, and actually I'll say that get x.toString here, so I get a number, and then get y.toString. And if we did this correctly, it should be exactly the same that it is. So I just independently rederived the key using point multiplication, because that's what's going on here. So the public key x and y values are the same as when you bother to multiply them out. So that's all that's really going on here is a public key is the private key times g, which is the base point of the curve. So now with my public key, we look at things like we just printed out. I can see what it looks like as a hex string or whatever. In the case of in this case, the string is always a base 16 or hexadecimal string here. Now this is in compressed format. So I mentioned in the last video that public keys can be either compressed or not. And they're always compressed by default. You basically never have to worry about this, except you're going to see this compressed variable there and wonder what it means. In the old days of Bitcoin, you would see some uncompressed public keys on the blockchain, but there's basically no reason to do that anymore. They're just needlessly big. So all the public keys are compressed now. But what you can do is we can just for the sake of a sort of argument here, we can derive a new public key, bsv.public key, I believe it's from point if I remember this correctly, public key dot point, And then instead of, let's see here, I think I have to do something like, from point. And then whether it's compressed or not, I'm going to say it is not compressed. Public key 2.2 hex. So this time it's much longer. So this is what an uncompressed public key looks like. Now this matters because basically when you create the address, which we'll see in the next video, basically, that you get a different address. So it actually does matter whether the public key is compressed or not. And that's why the private key and public key both have that data in there about whether it's compressed, because it's going to get you a different address. So then I can do finally as one final demonstration here. So I can, of course, import my public key in if I want to do something like that. Like somebody shares me a public key and I want to import it. I could do it from hex is probably the most convenient way to do this. So I create a new public key from hex, and I should get back out the same public key again if it looks correct. And I'd say that looks correct to me. That's the same thing. So that's basically what you would do if you're importing, outputting public keys. You always generate the public key from a private key. And it matters because public keys are hashed to get addresses, and addresses are normally what you use to send and receive money. But actually, public keys themselves show up quite a lot. So in order to do all sorts of advanced things like encrypting a message to someone with ECIES, which is another thing we'll cover later on, and things like Diffie-Hellman, which is involved in ECIES, involve using the public keys directly. So the public keys do matter. It's not just about generating addresses. The public keys are the sort of the asymmetric cryptography part of this that really matters. If you want to do any type of any of the sort of the crypto, you're going to end up using public keys.
Actually, to just a small comment, when you send the money to an address, to reclaim the money, the recipients needs its address and the public key. Like the part of the script requires the public key. It's not that it just disappears.
Yes.
Right. So
yes, when you spend it, you put the public key in there, and the anybody can verify that the public key hashes correctly to the address. Yeah, good point. Okay, so let's just glance at the code really briefly so that people can see that and the documentation in a second here. So I'll just really quickly scroll through the source code because it's kind of interesting. So this is publickey.js, and as usual, there's sort of a bunch of extra code that mostly doesn't matter. It's other ways to format things and things that you don't actually have to worry about most of the time. So you can see things like somewhere in here we have, here, I'll just search for things like BN. Actually, I'll search for point is really what I'm going to do here. So things like the from point method is kind of interesting. From point. So this is just where it inputs a point, and they have put a lot of the code in the constructor, so you can't see the real code here. A lot of it's in the constructor and other sort of methods throughout here. But anyway, that's the source code, and all the other stuff in here are basically things like validating them and so on, which you'll get if you input a public key and it's invalid. It can't happen, and so you'll get an error. So a lot of it's just stuff like that, like making sure it's valid. All right, now let me quickly go to our documentation as well and just glance at that so that people can see what our documentation looks like for this. So we have documentation for private keys, public keys, and addresses, and this shows you basically the same type of thing we just went through, which is different ways to generate a public key, output it, and input it back again in hex format. So unlike private keys and addresses, there is no standard way to encode this with base 58. It's just hex strings. Okay, anything else? Did I miss anything, guys? Any other questions in general?
I think we're fine. Just have to remind to the users that they should go to moneybutton.com and that kind of stuff.
Sure. So all the users should visit moneybutton.com and check out we have links to everything, obviously the main Money Button app, but also links to our documentation. That's also available at docs.moneybutton.com, and our Telegram group where you can talk with us directly or just talk with anybody else in the Money Button community to get help with whatever it is that you're working on. including MoneyButton itself, but also this library BSV. So that's t.me/moneybuttonhelp. All right, then I guess we'll resume in the next video on addresses.
Awesome.
Great.